So in the previous lectures, we have gone through the geometric transformation, importance of CAD-CAM, how the 2D geometric transformation varies, difference from the 3D transformation. We have discussed what are the applications of this geometric transformation. So now those were the CAD part, means computer designing part, modeling, and then transformation. Then now we will go for CAM part, computer aided manufacturing. Why we require this? What are the use of CNC machine tools? So we'll go for history of the CNC introduction, how they look like, elements of CNC, block diagram of CNC, how CNC works, feature of CNC machine, CNC programming basics. So history is that the first CNC machines were built in the 1940s and 1950s by Professor John T. Parson. CNC machine came into existence after evolution of computer around 1980. Modern CNC machines are improving further as the technology is changing variety of functions according to applications. So according to this, actually these CNC and NC machines are actually the part of automation. So nowadays all the industries are going for automation, means minimum requirements of labor, manual labor. So being the automated, what is the requirement that advantage is that productivity increases and this manual labor requirement is less. Then finishing is high in the CNC machines. So sitting at one place also we are getting information what is going on the shop floor. So that's why that automation came into picture. And in automation, the functioning of machines also become an important part. And that's why this existence of CNC and NC machines came into existence. And what is CNC machine? CNC is computer numerical control, in which the data handling, control sequences, and response to input is determined by the onboard computer system at the machine tool. So these are the requirements, and they are the numerical control system. NC means numerical control. It means you are putting the data using the use of punch step only. We are getting the data into the computer. But in CNC, all the things are controlled by the computer, onboard computer systems. So how do CNC machines look like? You can see. So this is on CNC machine, and the computer is already fitted mounted at the machine only. So there we can input the codes like this. Then servo motors playing important role for the control movement of the table and tool movement also. Slides are there, movement of the tool and this workpiece. So display console is there, controller is there, controller with Fanuc or Siemens, depends on the company. Okay, then that coding is required. So you can see chip collection system is there, coolant control is there, automatic tool changer is there. So all things come in the CNC. Computer numerical control machines means is equipped with the automatic tool changer, coolant control, automatic tool control, chip collection removal. All things are controlled on a computer only. The events of CNC machine is input device. So for functioning of the computer, we require the input data. So machine, so that input device is there. The machine control unit, machine tool is there, driving system is there, feedback devices, display unit. So input device, we are putting the data into the computer by G and M codes. The machine control unit, this process that input data. The machine tool does the actual function of the machining. Then driving system is controls the servo motor, controls the functioning of tool, and driving means control of the work table also. Feedback devices means even some air comes, even short circuiting comes, then that feedback comes into picture. Then display unit means the display of the codes as well as the functioning is displaying on the display unit like monitor. So in this diagram, you can see the basic functioning, basic process of the CNC machine is there. So input device is the coming, then machine control unit, then this data processing unit, control unit, then machine tool. Okay, the machine, this motion data is coming in driving system, then machine is driven by the driving system, then feedback device like velocity, position, miscellaneous, then miscellaneous functions are there, then display unit is there. So these are the basic arrangement of the CNC machines. Then open loop and closed loop controls. So in this feedback system, there are two things in the CNC machine: open loop and closed loop. In open loop, there is no feedback. So you are giving the input, and then machine is doing the work. Then you getting the output only. So there is no feedback where we are putting the right things, right pictures are coming. So, but in closed loop control system, feedback is there. Whatever the work is going on, whatever the data is displaying, all the feedback being taken. So that is the difference between the open loop and closed loop control. So in open loop system, slide may overshoot or may not reach desired position because of inertia, wear and tear and friction. Hence, inaccurate machining is there. So there is no feedback system. So whatever the inertia, wear, tear and friction is there, so you're not getting the feedback. whether the machine is running good or machining is getting accuracy or not. But in closed loop system, the position sensors are used to correct the slide and achieve higher accuracy and repeatability. So that's why closed loop systems are gaining importance. So in closed loop, you can see a stepping motor, pulse train, gear, work table, lead screw. But in closed loop, you can see the position sensor, whether the wear tear is there, higher accuracy is going, we are getting the side movement is getting okay or not. So this way, closed loop and open control loop systems are there. Then how CNC works? So how CNC works? By the use of G&M codes. We are getting the input by use of G&M codes. In whatever happening in the this NC machines, we were getting putting the data is a punched the step punch step where we are inserting the data into form of holes. But nowadays in CNC whatever GIM codes are there. So there are number of values and coordinates. So each number of code is assigned to a particular position. So we are typing the manually in CAD or by machine operators. So G and M codes are automatically generated by the computer software. We can write also, but in some softwares of the CNC, if you are designing the system in CAD and you are inserting that design into the softwares, then the G codes are automatically made. So in the earlier in the starting of CNC, we were writing the G and M codes, but nowadays CNC machines are equipped with the automatic conversion of the design into CNM codes. The features, what are features of CNC machinery? So the tool or material moves automatically. So there is no extra work is done to move the tool or material. It will move automatically, so there is no manual control. So tools can operate in 1 to 5 axes. So variation of the axis is very high. Larger machines have a machine control unit which manages operations. So movement is controlled by motors and actuators. So the servo motors are there, very high, low, high starting torque is there. Okay, so movement is controlled by motors, feedback required by sensors, transducers. Tool machines are used to change the tool automatically. Then coolant is made on and off automatically also. If you are writing the command, we can change the tool automatically. Feedback is provided also at its place. So they are the main features of the CNC machine. So CNC programming basics means CNC instructions are called part program commands. So whatever the program we write in the CNC, that is called the part programming. So when running a part program is interpreted one command line at a time when all lines are completed. So you are writing the command line wise, block wise. So it executes line by line. Commands which are also referred to as blocks are made up of words which begin with a letter address with a special value also, numerical value. So commands we write in the form of starting with the some code name, then letter address name, and then numerical value also. Then what is the difference between CNC and DNC machines? So in CNC, what happens? There are number of machine tools and there are number of computers. But in DNC, what happens? All the works are controlled by central computer. That is the difference between the CNC and DNC. So in CNC, remote controlling of operation is not possible, but in DNC, remote controlling is possible because central computer is available for this controlling. CNC is integral part of the machine, but DNC is not integral part of the machine. DNC computer can locate at a distance from machines. CNC transfer machining as instruction, but DNC manage the information. CNC computer control one NC machine, but using DNC, programmer can control more than one NC machine. CNC have low processing power when compared to DNC. So DNC have high processing power than DNC. CNC. CNC software is to increase the capability of the particular machine tool. So DNC not only control the equipment but also serve as the part of management system. So advantage of function of DNC, DNC eliminate the punch step and tape reader. So storing NC part program is very easy in the DNC. In CNC machining process, the memory level of machining is too small. In DNC machining storage is very high. Data collection, processing and reporting is very easy in DNC. So in components of DNC, central computer, bulk memory for storing program, communication network, NC machines are there. So CNC programming, there are some important things that we have to know. That could be the CNC programming works on the coordinate systems. It may be the units in the inch variation inch or millimeter like this. So in incremental system, it may work absolute system. So for CNC programming, coordinate systems, we can use incremental absolute both. So coordinates x, y, z, rx, ry, rz, feed rate is important, spindle speed is important, coolant control is important, on, off, flat system. So all things are written in programming. So programming consists of this coordinate system with an incremental absolute system, units, coordinates, then feed rate, spindle speed, coolant control, off, flood, mist, on, off, tool control, tool and tool parameters. So programming consists of series of instructions in form of letter codes. So there are some G codes, like these are called preparatory codes, which is used for initial machining setup and initial machining conditions. N codes specify the program line number, which is updated by the machine control unit line by line. Axis codes X, Y, Z. So used to specify the motion of the slide. Feed and speed codes like F and S specify the feed and spindle speed. Tool codes T, tool number which tool used for which operation. Miscellaneous codes are M codes, which is for fluent control, in program and off program, like this. So there are two types of codes used in the programming, G code and M code. G codes are called the in machining setup, and miscellaneous codes M with the coolant control and normal functioning of the machine. So common format of the block is that N50. Suppose this is the sequence number. In N50, this is the block number. The machine will operate from the N50, then 51, 52, whatever number you have given in the program. That is the sequence number is N50. Then preparatory function means G90, G01 means what functions will for machining conditions in incremental system, or what rotation or counterclockwise, like this. In dimension words means how much x-axis, y-axis you will want to, then feed rate, how much feed rate you want, a spindle function, speed of the spindle, then tool function, which tool, machining function is a spindle stop, a spindle coolant down, like this. So this is a common format of the this G code and this block program of the CNC. Means sequence number, preparatory function, dimension words, feed rate, spindle function, tool function, machining function. Okay. So individual words are there especially. So programming key letters O of program number, N sequence number, G preparatory function, X axis designation, Y axis designation, Z axis designation, radius, field rate, spindle speed, tool length, tool radius, tool designation, miscellaneous functions. So these are the common key letters. So table of important G codes, some of the important G codes which are very important for the learning for as well as for the comparative purpose also. So we have to hear the basic codes which you have to remember. Watching Viva in interviews, like, and also get young also. So some G0 rapid transfer motion, movement in air, then G01 linear movement, G02 circular movement clockwise, then G03 counterclockwise, G17, G20, G21, yeah, G21, this G40, G41, G42, 43 are the important codes, G codes, which are very important, which to be remembered in common use. G43, G44, G49, G80, G81, G82, 83, G90 for absolute positioning, G91 for incremental positioning. So like these different functions are there. The important M codes for miscellaneous functioning of the machine, like M00 program stop, M01 optional program stop, M02 program end, M03 spindle clockwise on, M04 spindle counterclockwise on, M05 spindle stop, M06 tool change, M08 coolant on, then M09 coolant off, M10 clamps on, clamps off, M30 program stop. So like these are the basic commands which are asked, which are required for the this writing the program. What the advantage of CNC? That easier to program. We can easily change the command for the required machining. So easier storage of existing programs are also there. Easy to change the program is also there. Avoid human error. Productivity is high. CNC machines are safe to operate. So complex geometry is produced as cheaply as simple ones. So in usually generates project tolerance and manual machines. So these are the basic advantages of CNC machines. Then what are the challenges? That for the operation of the CNC machines, we require some skilled operators. So costly setup, investment is very high. Initial investment is very high. So computers programming language knowledge is required also for the operators and management person also. So maintenance is also difficult for the CNC machines. So there are challenges. The summary means what we have discussed. The advantage of CNC system is that the operation of the conventional machine is removed and the part production is made automatic. So we can go for complex part. The complex part can be also done in CNC. Okay, production rate is high. Automatic production is there. Reduces the labor work and hence highly efficient in the manufacturing process. So if you will go for the some data case study, you will see that well generally use the CNC machines to achieve its manufacturing targets. For manufacturing works of large scale, it is difficult to work with manual machines. They are time consuming. So for large works and mass production, and very difficult with the manual machines. So they are time consuming. So CNC machines have their wide scope because they are easy to handle. So the work becomes easier and jobs are done with perfection. So that is the main thing. Surface finish is very high. Then this finishing is very high. Then productivity is very high. Manual requirement is less. There is less chance of error also. Okay. So continuous production of mass production of the larger scale. we can go for this CNC machine. So these are the requirements of CNC machine. So this is the CNC machine has the basic of automation in the now in the industry. Okay, thank you. We will go for the programming part next in the class. So thank you for patiently listening. Thank you.